Okay, good morning, afternoon, or evening. Today we're on our 8th day and we're looking at area between two curves. This may be a day where we have to do this in two parts. We'll see. There's about 4 or 5 different kinds of, well, actually maybe about 4 different kinds of questions that come in this area. Okay, it's the same as doing integrals for area under the curve, except now we're going to have two curves, one that's going to bound it in the upper area and one that's going to bound it in the lower area. So we're going to look at the theory first, and then we're going to look at area between a line and a curve, area between two curves, and an area between a curve and endpoints, like maybe between the x-axis and a curve, or the y-axis, or not the y, the x-axis and a curve would be one example. Maybe then you might do two parabolas. You might do two lines with two vertical endpoints, things like this. So let's look at the theory part first as we get started here. So let me just get set up here. It's my marker. And the theory is really quite simple. And as long as your integration skills are there, you'll have no problem with these types of questions usually. It's a couple of things you have to be aware of, and then we'll go through those as well here. So the theory between area between two curves, and we'll just kind of draw a little sketch. Let's say that we had a situation where we had a parabola like this, and then a line, let's do a different color here, like this. And then we had it intersecting in 2 points like that. So we could actually calculate this area here between those two curves. We'll call this point B and this point A, B being the rightmost point and A being the leftmost point. Okay, and the area between two curves would then would be the integral of from B to A, whatever those points of intersection are, of the top curve, which will be the green curve, we'll call it f of x1, subtracting the bottom curve, which is going to be the blue curve, which we'll call f of x2. Okay, dx. Now this has to be in brackets. Okay, so you have to do that subtraction before you do the integral. Okay, so you would subtract those two functions, and then you would do the integral from the intersection point of B to A. Okay, so this is called, the green one is called the upper limit. Okay, and that's basically the upper curve. And the blue one, of course, is then the lower curve or limit. So it's important that the lower one in between, you notice that blue is above green here and here, but it's not the upper limit because we're just looking at this section that bounds the areas. This bounds that area here, this semicircular kind of semicircle shape, is bound on top by the green and on bottom by the blue. So that's why this is the upper limit. This is the lower limit. Okay. And this is basically how we do area between two curves. Now, this is an example of a parabola and a line. You could have two parabolas, one curving this way, one curving the other way. You could have just a line in the x-axis with two given endpoints and something like that. So let's do our first example. I got about 4 different examples. We'll see. It might be a long video today. We'll see. And maybe a 2-part video. We'll see how it goes. I'm going to hit my clock here. So as we're going. So our first example that we're going to do is, let's just do a really, really simple example of a line and a curve like this, a parabola and a line. So let's do an example of area, let's say a line and a quadratic. Okay, so let's say find the area between, okay, we'll do a really simple one, not like a real simple quadratic and a real simple line. Y equals x squared is the simplest quadratic, and y equals 4x is a really simple line. Okay, so the first thing we can do here is we kind of have to know which one is on top, which one is on the bottom. When we're doing this, you're not sure all the time, but this is going to open up. We know that y equals x squared has a 0, 0 intersection point. And we know that so does the this one has a 0, 0 intersection point. So it's probably going to be like that. It's probably going to have the line on top. So let's just do that in red here. So say something like this might be what it looks like here. Okay, so the first step that we're going to do here, we'll do this all in black so we can see, is we want to find these two endpoints. So step 1, find the intersection points. Okay, so how do we do that? Well, we basically, y equals this, y equals that. So we equal them together. So we go x squared is equal to 4x. Okay, and what we have to do is use quadratic factoring or a quadratic formula or something like that, depending on if you can factor it or not, to figure out what the x values are. So what we're going to do is we're going to make it equal to 0. So we're going to make this an equation of bringing 4x over, so subtract 4x on each side. And there's our quadratic equation. Now you could use quadratic formula, negative b plus or minus the square root of b squared minus 4ac over 2a if you can't factor this. But this is really easy to factor. So if we take an x out, we get x times x minus 4 is equal to 0. So that's going to give us two intersection points. X can equal 0, or, as we allude, so this would be the 0 here, it could equal 4. So this point here is 4 something, and this point here is 0 something. So there is our equation that we need. Now, do we need the y points? You could figure out what the y points are if you wanted. So if you put it in here, 4 times 4, this would be 16, and 4 squared would be 16. Makes sense, right? Okay, and this one, put 0 in, they both give you 0. So you could do that if you need to, but just to help you visualize it, but you don't need them because we're going to use the x points as our a and b. So now in step 2, we are going to write out the area integral. Okay, so that would mean that we want the area, which is going to equal from 4 to 0, f, the top limit. So if you look at our formula, that's y equals 4x is our top one, right? Right there. So we're going to say 4x minus x squared. Okay, so there's our integral that we have. And now we have to go and use integration rules and work it out. And that's work out the integral in step 3. Step 3 is to solve the integral. Okay, so that means that area will equal, okay, so it's 4x squared over 2 minus x cubed over 3. Okay, and that is from 4 to 0. Okay, and then we can reduce this one. So the area then is going to equal 2x squared minus x cubed from 4 to 0. So the first one is going to be 4 plugged into it. The second one is going to be 0 plugged into it. So let's go ahead and do that. So this is going to be 2 times 4 squared minus 4 cubed. Everything minus a 0 because everything's going to work into a 0 for this one, right? So we can just kind of shortcut it a little bit. So this would be 16 times 2, which is 32. Oops, forgot to put the cube here. The third underneath it. We better make sure we do that, right? So this would be 32 minus 64 over 3. Okay, and then we get 32 over 3 square units. Okay, almost forgot that 3 there. So make sure you put that in. Okay, and if you're not sure how to do this, just change this into thirds, times it by 3. So this times 3 would be 96 over 3, subtract 64 over 3. Okay, and that's how you do the first example. Those are the simpler examples. A line and a curve. Okay. Let's try let me get my page out here. Let's try 2 curves. Let me get the right page. No. Okay, so the second one I want to do, 2 curves we'll do at the end here. Let's do the area between, so example 2, let's do the area between well, let's say curve, the x-axis, and 2 endpoints. Okay, so sometimes let's just say that we have a situation like this, and we want it from here to there. We want this area here. So let's set one up. Let's say our curve is y equals 3x squared plus 2. The x-axis which is the x-axis. If you think about that, that means that I'm telling you that y equals 0. And I'm going to say from, let's just go from -2 to +2. X equals -2 to x equals +2. So this is -2 here, and this is +2. And this is y equals 0 right here. And this is 3x squared plus 2. Okay, we know that. How do I know it's above? How do I know that this is a square here? How do I know that this isn't going to cross the x-axis? Well, if you equal it to 0 and bring it over, you have a negative. If you equal this to 0 and then bring the 2 over, you have a negative, and then you divide by 3. You can't take a square root of a negative number, so that means it's not going to cross the x-axis. That's how I know that it's not going to be the upper and lower limit. So our upper limit, so then we're going to find, we don't have to find the intersection points this time because they tell us these two endpoints. And we know that y equals 0 is our bottom limit, and our top limit is the quadratic equation. So we write out the integral. Okay, this one's 2 and -2, rightmost to leftmost. Okay, this equation first, y equals 3x squared plus 2 minus y equals 0, right? Okay, and then dx. So that's pretty easy. So that's the area equation. So now what we do is we integrate this equation, which is just going to be 3x squared, don't need the equal in there, plus 2 dx. Okay, and do the integration now. So this would be 3x cubed over 3 plus 2x. Okay, plus c, but since we're doing definite integrals, and that's going to be from 2 to -2. Okay, and we can simplify that a little bit. To be x cubed, because the 3's cancel out, plus 2x from 2 to -2. Okay, so that's going to give us, as we calculated here underneath, 2 cubed plus 2 times -2 minus -2 cubed plus 2 times, I put the -2 in there. Getting rusty here, right? We're doing 2 for the first one, not -2. My mistake. Should be a 2 in there, right? Because that's the first one. -2 goes here. My mistake. Okay, so 2 cubed is 8 plus 4 minus -2 cubed is -8 minus 4. So we've got 12 minus a -12. So that's going to give us 24 units squared. Okay, so there's an example of when you have two endpoints and the x-axis and two endpoints and then the curves above. Sometimes the curve might be below, So then that would be, you'd start with 0 minus the curve. If you had one like this would be y equals 0. That would be your upper limit. You'd start with 0 minus this instead. Just remember that the upper limit always comes first. Okay, so you have to kind of figure that out. And if you're not 100% sure, you can always pull out Desmos and put the graph in, two graphs in, and see which one's on top and which one isn't. To get it visually, or use a graphing calculator or something like that. Okay, let's do our third example now. Let's do the area between two curves. So let me pull one up like that. Those are the most interesting ones. See, we did one with two endpoints. We did one with a line and a curve. Now we're going to do the area between two curves, two quadratics. So this would probably be our most common. So the area, this is example 3, between two quadratics. Okay, so I have an example here that I've got. So let's say the one quadratic is y equals x squared, okay, plus 3x plus 2. And the second example is y equals negative x squared plus 5x plus 6. Okay, and then the question is, find the area between the two curves. Okay, so this is where we go back to, we got to find those endpoints. So let me just get my clock back because I switched my page over here so I can see where we are. Okay, we're about 22 minutes or so, so this might be our last example. Maybe I'll do one more. We'll see. Okay, so what we know is that this one is a quadratic that opens like this. And this one is a quadratic that opens upward. So it's more than likely going to be like this, unless this one is way above it. Okay, so we're going to say more than likely we're going to have the negative quadratic there and the positive quadratic, x squared plus 3x plus 2 on the top here like this. So the upper limit is going to end up being this negative quadratic, and the lower limit is going to be the other one. If we're not sure, okay, you're like, I don't know for sure, here's what you do. You just go into pop in Desmos here. Let me bring that over here. Okay, so if you weren't sure, you just go Desmos. You could do this manually too, but since we have the graphing calculator available, we could just go, okay, let's put in x squared, y equals x squared, okay, and then we got plus 3x plus 2, okay, like that, and then you can pop the other one in, so that's that one, and then minus, or y equals, sorry, minus x squared. Okay, so those aren't intersecting yet. Plus 5x. Still not intersected, plus 6. Okay, so we do see that, and we're going to get our intersection points here. We can see them already, but I'm going to show you how to calculate that because you're going to have to show that manually. So there, the upper limit is the blue one, in fact. Okay, so that just double checks it for us if we're not sure. Okay, you could have the intersection points and look at them right there on the graph as well. Okay, so let's find those intersection points. Okay, so finding the intersection points, you could just use the Desmos graph, but I would recommend being able to solve it manually because you might not have a computer available during an exam or something all the time. So here we go. So let's find the intersection points. Point B and A. So that would mean we're just going to equal them together. X squared plus 3x plus 2 equals negative x squared plus 5x plus 6. I'm going to bring everything from the left side to the right side. So I'm going to add x squared. So that's going to give you 2x squared over here. I'm going to subtract 5x. So subtract 5x. That's going to give me negative 2x. And I'm going to subtract 6 minus 4 equals to 0. Hey, we got a common factor here. So we can take a common factor of 2 out to get x squared minus x minus 2 equals 0. Well, so we can divide both sides by 2, so that cancels that 2 out. And 0 divided by 2 is still 0 over here. And then our 2 x's, then our x minus 2, and x plus 1 equal to 0. And that would mean that x minus 2 equals 0 or x plus 1 equals 0. So we've got x equals 2 or x equals negative 1. So if we know this one's negative 1 over here and this one is 2 over here. Okay, and if we checked in our Desmos diagram, it should match up. Where's my Desmos diagram? Okay, so there's our negative 1. And right here is our 2. Okay, so it matches up nicely. So we're on the right track. Okay, so once we do that, we do the area curve. So we go area equals. Okay, so we got to put the upper limit first we're going to integrate from the rightmost one, 2 and minus 1 here. Okay, and now the first curve that's going to come is the upper curve. The upper curve is negative x squared plus 5x plus 6. And then we're going to subtract the lower curve, which was the one that was opening upwards. And this has to all be in brackets so that you can change all the x squared plus 3x plus 2. Okay, so then we have to take this negative and jump it across here. Okay, so that means we've got negative x squared plus 5x plus 6, and we got negative x squared minus 3x minus 2. So when we do that whole simplification, we get negative 2x squared plus 2x plus 4. Okay, and I forgot to put dx out here, right? So this would be dx, and then this would be dx. So now we do the integration there. Okay, so doing the integration is our next step. Okay, so we'll integrate this. So this is negative 2x cubed over 3. Okay, plus 2x over squared over 2 plus 4x over 1. Okay, so we can do a little bit of simplification, and that's from 2 to negative 1. So a little bit of simplification. Let's put it up. I was going to go, let's undo that one. Let's do it in a different, let's just divide this so we don't get confused here. Okay, so now we're going to just plug in our numbers. Give ourselves a little more space. So, okay, so if I simplify it to negative 2 thirds x cubed plus, this will cancel out, x squared plus 4x from 2 to negative 1. So let's plug in our numbers. Negative 2/3 times 2 cubed plus 2 squared plus 4 times 2 minus the whole thing of 2/3 times negative 1 cubed plus negative 1 squared plus 4 times negative 1. Okay, so this would be negative 2/3 times 8. So that'd be negative 16 over 3 plus 4 plus 8 minus, and this would be negative 1 times that would be negative 2/3. This would be plus 1, and this would be minus 4. Okay, so then we have negative 16 over 3 plus 12 minus negative 2/3 minus 3. Okay, so then we've got to figure out what these are in terms of our numbers. So this is negative 16 over 3. What is 12? Well, 12 times 3 is 36. So that's 36 over 3. Okay, minus this is pretty easy to do. 2/3 negative, and then how much is 3 in thirds? That's minus 9/3. Doing your fraction rule, so this is 20 over 3 minus negative, negative, what does that work out to be? Let's see if I did this. I forgot the negative out here. I got it right there, but I didn't get it right here. So that's a negative, 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 negative. So that's positive there. So that's 7 over 3 here. And that's negative. Okay, so you got to be careful with that negative there. You see I missed that there, and I could have thrown us off, but I worked it out before, so I just caught it there. So if we do that, a negative, negative again, that'd be 27 over 3, which would equal 9 units squared. And that gives us the main 3 types. And looking at our timeline here, what do we got? Main 3 kinds of examples here. Okay, so that's about 33 minutes. So I think we'll do the practice stuff tomorrow. Okay, so just reviewing here, let's go back to the 3 examples. Okay, an example between a curve. Our first one we did was just a line and a curve. Okay, so you got to make sure you know which one is on the upper limit and which one's on the bottom limit. Solve for the 2 endpoints. Once you get the 2 endpoints, you plug in the values where the upper limit goes first and the lower limit goes second. Upper minus the lower. Then you integrate it, and then you plug in your numbers for your definite integral. Okay, and we also did one with a curve and 2 endpoints. Okay, and then the last one we did was 2 quadratic curves or 2 curves. Okay, and that's basically the 3 main kinds of examples you get. I could do another 1 or 2, but I think we'll just take a look at the practice assignments that I'm going to give you for tomorrow. There's a few of them in there. You can use that to fill out your values. So there's a whole pile of them here. I wouldn't be doing all this stuff because this is a big section. Okay. It says sketch the region bound by the graph given its occasions, find the area enclosed by the region. So here's area, there's 2 curves and 2 endpoints. I wouldn't do all 9 of these. That'd be crazy. Maybe do like 3 and and 6 here. Here's x cubed and x squared. If you're not sure which one's the upper lower limit, you can always put them into Desmos. Okay, part B here, maybe find the area of the graph between y equals x, y equals 2x, and the line x equals 2. So that's going to give you the area. You have to draw that out, or maybe do one in this one. Okay, C here is the x-axis and a curve. Okay, and the D here is two curves. So this is the two curves. This is the x-axis and a curve, which we did, and this one here is basically a curve and two endpoints. So maybe do 2 in B, 2 in C, or 2 in B, maybe 1 in C and 1 in D, or 2 here, 1 here, and 1 there, 2 there. So focus on part B, C, and D mainly, because those are the ones I'll ask you. Then if you go to the solution part, if I flip this backwards here, the solutions are here. Okay, this is not me, this is Mr. Friesen's one. I might work these out here so that they're standing upright, but the solutions will be there for you. Okay, so do a little bit from part B, C, and D tomorrow. Okay, other than that, I'm going to stop the video at this point, and you can just work on that tomorrow, and then you can see that the integration hand-in is the last thing that we're going to do in this unit. And then I have a video outline of the quiz there. It's hidden right now, but I will get that in there and have that opened up for you as well. Probably going to update that for this year as well. Okay, so good luck.